Okay, so the next section then looks at prediction. So probability as a prediction. Okay, and this is on page 201. Okay, so let's just go straight into the example because it's always best to see this with your examples. So it says a company has developed a new brand of toothpaste and tested the toothpaste on a group of people. The results of the test showed that 1 in every 5 people who used the toothpaste ended up with black teeth. Based on this data, how many people are predicted to have black teeth after using the new toothpaste if a group of 200 people tested? Okay, so we can use the probability fraction to estimate the number of people whose teeth might turn black if the toothpaste were tested on 200 people. Okay, so because we have the probability and it refers to the likelihood of an event occurring, we can then use this probability to predict future outcomes. Okay, so we're basically using the historical data to predict a future outcome. Okay, so if they tell us that the results of the test show that 1 in every 5 people who use a toothpaste ended up with black teeth, that means we just take up that probability of 1/5 and apply it to the population that is being tested. So since it's 200 people being tested, the equation would just be 1/5 times 200. 200 referring to the total number of people, 1/5 referring to the probability of the people getting black teeth. So this is using our probability to predict how many people to predict the number of people who will have black teeth after using the new toothpaste. Okay, and we can predict it by just saying 1/5 of the population being tested will have black teeth according to the previous probability provided. Okay, so the next section talks about theoretical versus experimental probability. Okay, so with theoretical probability, we have the purely mathematical calculation of determining the probability of an event occurring, which is the one that we have used thus far, where we say the number of favorable outcomes over total number of possible outcomes. Okay, so that's how we already worked out rolling the die. We said a 1 and we got 1 out of 6. But there's also an experimental probability which refers to actual results obtained when calculating the relative frequency of an event after repeated trials. Okay? So for instance, if you have the experimental probability, this is now equal to the number of favorable outcomes. So I'll just write it as experimental probability. Okay, so remember with the experimental probability, it's in the word experiment, okay? So since it's an experiment, we have actual results obtained to calculate this probability, okay? We are not just using the possible events and outcomes, okay? So if we have experimental probability, it will be equal to the number of favorable outcomes divided by the total number of events. Okay? So basically, the more times an experiment is repeated, the closer the value of the experimental probability comes to the theoretical probability. Okay? So let's look at an example and see where we have to calculate the experimental probability and the theoretical probability so that we can see the difference between the two. Okay? So the work example says a pregnancy test states that it has a 98% accuracy in determining whether you are pregnant or not. A researcher decides to test the accuracy of the pregnancy test by testing 50 pregnant women and seeing whether the test gave a positive result. Okay? The first question says, what is the theoretical probability of being tested positive using the pregnancy test? Okay? So the theoretical probability is 98%, which has been given in the question. Okay? It's not being derived from the experiment which this researcher is deciding to do. Question 2 says, what is the relative frequency experimental probability of being tested positive using the pregnancy? Give your answer as a fraction, as a percentage. Okay, so when we're working out the experimental probability, we need the number of favorable outcomes. In this case, the favorable outcome is testing positive. So the frequency of testing positive is equal to 47. Okay? And then we have the total number of events. Okay? The total number of events in this case would be equal to 50. Okay? And as a percentage, since the other theoretical probability is given a percentage, you could work this out in the percentage form. Okay? And you would have gotten 94%. Okay? So, would you rely on the results of this pregnancy test? Okay? So, if you see that your experimental probability is equal to 94%, the theoretical probability is equal to 98%, you wouldn't rely on this pregnancy test. Okay? Because you have approximately, in this thing was 3 women. In terms of percentage, it would be 6% of the tested women were actually pregnant and they tested not pregnant. Okay? So, because of that, you wouldn't want to use this pregnancy test because you could fall into that bracket of those 3 women. Okay? So the 6% that they're referring to in the answer is that 3 of the women tested not pregnant, which is 6% of the sample, which is quite high. And that is why you have a 94% experimental probability for testing positive, okay, using this pregnancy test. Okay, so that is the theoretical versus experimental. The only thing you have to remember with this is that we are just using the frequency of an event, okay, which is just the number of times an outcome has occurred to work out our probability. Okay, so that's why they call it also experimental probability or relative frequency, okay, of an event happening. Okay, so that's why they call that, because after a repeated number of trials, then we can say is the number of the times the event occurred relative to the number of trials of the event. So the number of favorable outcomes relative to the total number of times we ran the tests or we did the trials. Okay. Okay, perfect.